So now we're gonna start the real chapter in the book. This is the first chapter in the book that we need to do. What we did before the revision geometry, it was related to last year. So chapter 1, rational and irrational numbers, page 7. Okay, it's very important, this chapter. You're gonna focus with me from now on. The preceding one was a revision. You need it, but you didn't, you saw it before. This one, you didn't see it before. We're going to start by doing this part that we have two kinds of real numbers. We have rational numbers, we have irrational. What does it mean rational? What does it mean irrational numbers? Okay? Rational numbers first. What does it mean rational number? Okay, irrational number step by step. Okay, what is it? A rational number is a real number that can be written as a ratio and as a fraction of two integers. It means if I want to give you an example, for example, I can write 2 over 3. This is a rational number. Why? Because it's a fraction, okay? And the numerator and the denominator are both integers. And you cannot write, for example, 2.3 over 3 and say this is a rational. No, it should be a fraction with two integers, okay, for the numerator and the denominator. Irrational numbers, it's rational numbers, the second case, or it's a decimal that form is that it ends, or it's a repeating pattern. What does it mean? I can have, for example, if I have a decimal 2.3, this is a decimal, this is an ending decimal, or for example, 32. This is a pattern. We have a pattern 32, 32, 32. So the second kind of rational numbers are the decimals, and the decimals with ending and it ends 2.3. It's an accurate answer, or with a pattern, for example, 4.32, 32, 32, 30. So what does mean rational? We have two kinds of rational numbers, or the number that can be written as a fraction, or the decimal with an ending decimal part, or the repeating pattern. But listen to me, those two I can write as a fraction also, and I will go back to the preceding case, because 2.3, for example, I can write it as a fraction. It's 23 over 10, and then I will simplify it. And this one, we're gonna learn how to write it as a fraction later, the pattern, okay? So the original definition of rational numbers and the numbers that can be written as a fractions. If it's given a fraction, it's a rational. If it's given a decimal with a repeating pattern, it's a rational. And if it's given a decimal that has an ending terminal decimal part, also it's a rational. Okay, let's go now to the other one. Example of rational numbers I have here. 16 is the rational number. Half is the rational number. 3.56 is the rational. Minus 8. 1.333. This is with a pattern. It's a repeating pattern. Okay. Minus 3 over 4. Those are called all rational numbers. Can I write 16 as a ratio? As a fraction? Yes. We can write 16 as a fraction. What is 16? I'm sorry. I want to go back. What is 16? It's 16 over 1. I can write it 16 over 1. It's a fraction, okay? How are we going to write, for example, here 3.56? 3.56, if I want to write as a fraction, it's 356 over 100. And then if you want to find the final answer, you can just simplify this fraction and you will have it as a fraction. Now I want to show you how to write this one, 1.333, when I have repeating decimal as a fraction. It's very important to know how to write it as a fraction. I will go to the second part. Remark, how to write a decimal number whose decimal part is unlimited and periodic. So the rule is integer part plus period over 9 times. What does it mean? So I will give you this example. If you have 2.33333, it's equal, normally you see it 2.3 bar. So what is the integer part here? It's 2. It's 2 plus, sorry. What is the repeating part here? 3. So it's 3 over 9. Listen to me, this 9 you need to write all the time, but because we have 1 3, I put 1 9. And then I do here the same denominator to be able to do it. So if you want to see how I will do the same denominator. So I will have 2 over 1 plus 3 over 9. Then I'm gonna multiply this fraction by 9 to have same denominator. I will have 18 plus 3 over 9. What is 18 plus 3? It's 21 over 9. Now, if I have more than one pattern after, for example, here, 2.34, 34, 34. Also, it's 2 point, what is the repeating part? 34. And how many numbers we have? 2. So I put 99. And then also I do the same. It's over 1. I multiply 2 by 99. Okay? And then I add. I do the same denominator. So I will have 99 times 2. It's equal 198. 198 plus 34 over 99. And then I add 198 plus 34 is 232. Now, yani, miss, you're gonna ask me, like, if I have, for example, 621, how I gonna write it? Yes, I'm gonna write it 2.2621 over 39, because I have 3 numbers over 999, and then also, do the same denominator and find the final answer. So I will not give you that much big. I'll just give you, for example, one pattern or 2 pattern. Okay, so I'm gonna repeat again. So if I have, for example, 2.3333, so the repeating is just one number 3. So I just take the integer 2 plus and 3 over 9. Then I do same denominator times 9, numerator and denominator. So 9 times 2, 18. 18 plus 3, 21. If I have 34 and plus 34 over 99, and also the same, I do same denominator, and I continue my work. Okay? This is the rational numbers. I will pass now to irrational. Irrational numbers. An irrational number is a number that cannot be written as a ratio, as a fraction of 2 integers. I cannot write it as a fraction of 2 integers. It means I cannot write it as a fraction, for example, 5 over 2. It's not integer. And it could be a decimal are non-terminating, they never end, and they are not repeating. It's not a pattern. Let's see some example of irrational numbers. For example, square root of 17. If you take your calculator, you're gonna see that it's not an accurate number, and it's not an ending decimal, and it's not a repeating pattern. Pi, what is pi? You know what is pi? It's radical. Delicious. It's radical. It's 3 point something, okay? So if I check my calculator and I do radical 17 is 4.123105, so it's not ending. And pi 3.14 something, okay? So those are the irrational numbers. I still need to give you just the scientific notation for this time. And this is very important. Scientific notation. What does this mean, scientific notation? So to be in a proper scientific notation, the number must be written with a number between 1 and 10. Yani, you need to write 1 point, 2 point, 3 point, 4 till 9 point, and multiply it by a power of 10. What does it mean? If I have this number here, this one is not in scientific notation. I'm not allowed to keep it like this. It should be a number between 1 and 9, so it should be 3 point. 3 point what? 47 times 10 exponent what? If I am here, how I will go back to my number? Times 10 squared, 10 3, 10 4, 10 5. So it's 3.47 times 10 5. This is the scientific notation. Also, we're gonna see it with the application. It's very important scientific notation. I will keep the exponent for next time. Okay, so that's it. I'll give you another example for scientific notation before I end the video. For example, if you have 23.2. This is not in a scientific notation. It should be 2 point something. So you write it 2.32 times what gives me 23.2 times 10 exponent what? How I will do it? Okay, 2.3.22 times what will go back to 23. I'm moving forward, so times 10 exponent 1. Okay, so I'm here. How I will go back to 23? So I need to multiply times 10 exponent 1. And even you can use your calculator to check that. 2.32 times 10 1 gives you 23.2. I'll give you another example now. For example, 0.025. Okay, I cannot write it like this. It should be 1 point till 9 points. So I can write it 2.5. Type 2.5 times 10 exponent what? I'll go back to the, so 2.5 times 10 exponent what will give me 0.0. I'll need to go back. And it means times minus 1 minus 2. I'm going to make two decimals after 2.5. And after 2, I have before 2, 1 decimal, 2 decimal, so it's minus. So those are two scientific notation as an example for the scientific notation. I'll wait a little bit before I share the video to be sure that you will see the writing. And then that's it. If you have any question, as usual, you can ask.